Yeah, continuation of this mesh current analysis. Take one more third example. Yeah, how can we apply this mesh analysis for this given diagram? Only thing is we have to determine all the branch currents. The task is branch currents means what is the current in 10 ohm, 10 ohm, 10 ohm, this 10 ohm, this 10 ohm, and 24 ohm. This is a very easiest one. If we applied a mesh analysis, simple one. But before going to the mesh analysis, there is a current source here. What to do? How can I apply this mesh current? Because any meshes, if there is a current source is there, okay, it is difficult to apply the mesh analysis. So first step is, can we do something? Okay, something. Can we change this? Yeah, but we can't do anything here because look at this analysis. This 10 ampere, okay, is in parallel with this. Okay, this is something like that. Okay, you can say straightly means in this way you can draw here. It looks like that, something like this between this 10 10. Also it is between these 2 points. Yeah, so what I can do, can I change this voltage source so that something simplification I can do. Yeah, that is the first step I am doing. But how can I think that, so that I can change this, then do something? Yeah, this is all practice. So you have to solve as many as problems so that you will be going to understand how can I solve, because every problems are unique in their structures. Yeah. So what I am going to do? So this voltage source I am going to convert into current source. Yeah. So how to convert this voltage source into current source? 100 by 10. This is the 100 by 10, and this will become in parallel. These are all the basic things you may be knowing. Okay, how can I convert this voltage source to current source? If there is a series resistor, this 100 by 10, you did it, okay, 10 ampere, and that 10 ohm will come in parallel. Now look at these two. This 10 and 10 are in parallel here. These are the two in parallel. These are the two parallel. Yeah, 20 ampere and 10. Now again, I'm going to convert this into voltage. Because to solve it, yeah, so this is simplifications. Initially, it looks okay, very complicated. No, when I convert this into current source, because now these two are in parallel here. This 10 ampere and 10 ampere, and both are in same directions. They are going to be get added with each other. And this two. So now this two convert into voltage source. Yeah, that is a one voltage source. I've written here. Okay. Voltage source remain. So now I'm going to directly, because already in the last two videos, I'm shown given demonstration how to write the mesh equations. Uh, these are the three simultaneous equation. I can directly write here. I will explain how can I write. If you have any doubts, okay, I have earlier already uploaded two videos. Just refer those two videos. Coming to this first mesh, these are all my convention now. You can take any direction, but be careful, okay, how I am going to write the simultaneous equations. In the first mesh, these are the three resistors and voltage source over there. What is the total resistance? 30, that is 30 I1. Is there any currents? Okay, those are all in parallel, are with this first mesh. Yeah, this I2 is also common and I3 is also common. Yeah, and then these are in opposite directions. So that's why when coming to the I2, this 10 ohm is covered by this I2, and I1 and I2 are opposite. So that's why I written a minus 10 I2. And again, one more coming to this mesh. Okay. This is the one more register. Again, the I3 is also flowing. And again, I1 and I3 are in opposite, minus 10 I3. When I'm gone reaching here, minus 200, that I taken to the right side. One more time I'm repeating here. Take the first mesh, find the total resistance, 30, I1. Then in the same mesh, is there any currents are there? Okay. Means whatever the mesh you are taken with that mesh, in that element, is there any other currents is flowing with that mesh? Yeah. A 10 ohm element, this I2 is flowing. Yeah, minus 10 I2. Why this minus means these are the opposite direction. Why this minus I3? Opposite. Yeah, coming to this, okay, no voltage source. So What are the total resistance? 30 I2. And is there any common? Yes, 10. Y minus 10 because opposite. And is there any other resistance? Yeah, this is I3 minus 10 I3 0. Now third mesh here. What is the total resistance? 10 plus 10 plus 24. That is the 44 I3. Is there any I1? Yeah, this I1 is flowing this 10 opposite directions minus 10 I1. I means I3 and I1 are opposite. I3 and I2 are opposite. Yeah, minus 10. So these are the three I can directly write. And earlier videos, okay, I am also shown how to write these equations, or even directly we can write. These three equations we can directly solve using calculator. Use this link, this following link will explain to you how to use the calculator for solving these three simultaneous equations. 8.997, 3.97. Now, this branch current of 10 is I1 only. Then coming to this I2, 10. But this 10, no, I1 minus I2. I1 minus I2. I1 minus I2, 5.07. What about this 10? I2 minus I2. Yeah, 1 term. What about this one? I1 minus I2. So, like that, we can determine the branch currents.